Welcome to the next video in the series of discrete mathematics. In this video, I will talk about recurrence relation and modeling with recurrence relation. So if you are new to the channel, please subscribe the channel, and I have created a separate playlist for discrete mathematics. So in case if you want to learn the subject thoroughly, you should watch the videos in sequential order. So let's start. What basically is a recurrence relation? So to understand the recurrence relation, I am going to start with one simple example. That suppose I take an is equal to 3 times an minus 1. Okay. Now if you look at this expression, what is special about this expression? And here I also specify that suppose I say that n is greater than or equal to 1, right? And I also write a naught is equal to, suppose I say 1000, right? So if you look at this, this is an equation which has been written, means an has been written in the form of its previous term, like thrice of 3an minus 1. I can take more examples. Suppose I take an is equal to an minus 1 plus an minus 2. Now this equation has been written as sum of its two previous terms. An has been written as an minus 1 plus an minus 2, and suppose here I specify that n is greater than or equal to 2, and I also write that a naught is equal to 1 and a1 is equal to 1. Now there are certain terminologies which are associated with it. The first is that this condition that I have specified are known as initial condition, and this relation that I am writing, or this equation that I am writing, these two are known as a recurrence relation. Why they are known as recurrence relation? Because we can get the next term using the recursive approach. Means to get the nth term here, if you look at this expression, we are using n minus 1th term and n minus 2th term. If you look at this expression, we are using the previous term to get the next term. So this kind of relation is known as a recurrence relation. Basically this is an equation where an is represented as one or more of the previous terms of the sequence, right? And the condition given where the recurrence relation takes effects is known as initial condition. Means a naught is given to be 1, a1 is given to be 1, and the recurrence relation is taking effect at n is equal to 2, means it is making sense for n greater than or equal to 2. So in that case we call this relation, or this condition as initial condition. Okay. So before we move ahead, let us quickly look at this problem, that let an be a sequence that satisfies the recurrence relation an is equal to an minus 1 minus an minus 2, and it is taking effect at n is equal to 2, means this is true for n greater than or equal to 2. It means that I need to know that what is the value of a naught, which is 3 given in this problem, and what is the value of a1, which is 5, that is also given in this problem. And they are asking us to find the value of a2 and a3. So as you can see that using this recurrence relation, I can write the value of a2. So what will be a2? If n is equal to 2, it will be a1 minus a0. Now a1 is given to us, that is 5, and a0 is also given to us, that is 3. So this value will be equal to 2. If I ask what is a3, so again using this recurrence relation, it can be written as a2 minus a1. Now a2 we got in the previous step, that is 2, and a1 is given, that is equal to 5. So what we got is minus 3. So I hope you noted this important point, that to get the next term we are using the recurrence relation, and recurrence relation has been written by using or making use of its previous terms. Now there may be different kind of recurrence relation. Some of them may be using one term, or some of them may be using more than one term, right? So let us move to the next topic or next problem. So if I look at this example that is given here, they are asking me to determine whether the sequence an, which is given as two parts A and B, is a solution of the recurrence relation, that is an is equal to 2 times an minus 1 minus an minus 2. Now let us look at them one by one. So first they are expecting us to check that whether an is equal to 3n can be considered to be a solution of this recurrence relation, where an is equal to 3n is true for every non-negative integer n, means it is starting from 0, so that is why we are calling it non-negative integer. Now if I have to evaluate 2an minus 1 minus an minus 2, what it will be if I use the solution which they are providing as an is equal to 3n, right? So this will give me what? This will be giving me twice of 3 into n minus an minus 2 will be 3. Okay, sorry, let me correct it. I made a mistake here. Let me quickly write here in the bottom. So what I'm saying is that here we have twice of, and what will be an minus 1? If an is equal to 3n, then an minus 1 will be 3 into n minus 1, and minus what will be an minus 2? It will be 3 into n minus 2. So if I solve it, it is 3 into 2 6, right? 6n and minus 6, and here also I will get minus 3n and plus 6. So this 6 and this minus 6 is cancelled. In the end we are getting 3n, right? So this is nothing but an, which is given here, that is equal to 3n. So we noticed that an is equal to 3n is satisfying this relation. So that is why this can be considered to be a solution of this recurrence relation. Now let us look at the B part also. Here they are saying that what about if I take an is equal to 5. So here again, and this an is equal to 5 is true for every non-negative integer. So if I calculate 2an minus 1 minus an minus 2, this will be what? This will be 2 into 5 minus 5. This is a constant term. It is independent of n, means basically this is telling you that we have a sequence which is like 5 comma 5 comma 5 comma 5, so on. So if I consider this sequence as a solution of this recurrence relation, then yes, that solution is also satisfying this recurrence relation, because 2an minus 1 minus an minus 2 is equal to 5, and which is nothing but an. So here an is equal to 5 is satisfying the recurrence relation 2an minus 1 minus an minus 2. So I hope by now you are clear about what is the recurrence relation. Okay. So we discussed about what is the recurrence relation, and we took some examples, very simple examples, to understand that what it basically means. Now let us do some problems where we are going to formulate the recurrence relation, because in earlier examples that we have taken, the recurrence relation was given. So the first simple problem that I am going to take is related to compound interest, and it is given that suppose that a person deposits 10,000 rupees in a saving account of a bank which yields 11% per year with interest compounded annually, right? This is compounded annually. How much will be in the account after 30 years? So if I have to formulate this as a recurrence relation, suppose I denote that Pn is the amount, Pn is the amount in the bank or saving bank account, in the account after n years. We are using this notation Pn to represent that this is the amount after n year, right? Now it is very much obvious that if I have to calculate what is Pn, how I have to calculate. So at the end of n minus 1 years, the amount will be Pn minus 1, right? So this is the amount at the end of n minus 1th year, and on this amount, because the interest is being calculated annually and it is compounded annually, so whatever is available in the account at the end of n minus 1 year, 11% interest will be given to the customer. So 11% interest means that we have to calculate 11% of this, that is Pn minus 1 into 11 by 100, right? So this will look like Pn minus 1 plus 11 by 100 will be basically 0.11 Pn minus 1. So we are getting a relation that is Pn is equal to 1.11 times Pn minus 1. Okay, let me put it inside the bracket so that it looks better. Now this is just a recurrence relation, because you can see that to get the amount at the end of nth year, we are looking at the amount at n minus 1th year, and then we are just multiplying that amount by 1.11. Because initially the deposit was 10,000 rupees, so I can consider that P0 is equal to 10,000 rupees, right? So what will be P1? P1 will be equal to 1.11 into P0, and that will give me 1.11 into how much? 10,000. Similarly, if I have to calculate P2, I have to take 1.11 into P1. So that will be equal to 1.11, and P1 is nothing but 1.11 into P0. So that will be equal to 1.11 square into P0. And continuing like this, if I have to calculate amount after 30 years, so if it is P2, we are getting a square. If it is P1, we are getting 1 power. So if I have to calculate P30, I will be getting 1.11 to the power 30 into P0. So this will be a total amount in the saving bank account at the end of 30 year. In case if you are interested in calculating this, 1.11 to the power 30 into 10,000, it will be 228,922.97. So this much will be available in the account of the customer at the end of 30 year. So did you notice this thing, that in this problem what basically we have done? We have first tried to write one recurrence relation. And what is the recurrence relation? That we need to use some or one or more. I mean, this is important. We have to use one or more of the previous term. So here I just use one term, that is Pn minus 1, to get that what we are going to get in the end of next month. So this kind of problems can be solved using the recurrence relation. We are going to take more problems on recurrence relation. So let's wait for that. Okay. Okay. So let us look at the next problem. So in this problem, this is a very interesting problem, which is popularly known as rabbit and the Fibonacci sequence or number problem. So what is the problem? That a young pair of rabbit, one of each sex, is placed on an island. A pair of rabbit does not breed until they are 2 months old. After they are 2 months old, each pair of rabbits produce another pair each month, right? Find a recurrence relation for the number of rabbits on the island after n months. So here it is also assumed that no rabbit is dying at any point of time. So if you look at how the problem is formulated, before I formulate the problem, let us understand it, what is happening here. So you see that in the beginning, at the end of 1 month, since in the first month one pair of rabbit, one is male, another is female, is placed on the island. So at the end of 1 month, the total number of pairs will be just 1, right? Now they do not reproduce until they are 2 months old. So at the end of second month also, the number of pairs of rabbit will just remain 1, means the original pair, this pair will be there. Now this pair after 2 months past has become old enough to produce new pair of rabbits. So now let us consider that this is an old pair which I am placing over here, right? This pair of rabbit during third month produces another pair of rabbit, right? So at the end of 3 months, the total number of pairs of rabbit, will be 1 is the original pair, and 1 produced during this month is equal to 1 plus 1, so that is equal to total number of pair is equal to 2. So at the end of first month 1 pair, at the end of second month 2 pair, at the end of third month 1 plus 1, that is equal to 2 pair. Now in the fourth month this young pair will remain just 1 month old, right? So it is not going to produce any new pair, but the original pair which is here will again produce 1 pair of rabbit, because they are producing 1 pair of rabbit each month. So this original pair is going to produce 1 more pair. So we have another pair. So this is 1 pair, this is another pair. So 1 pair was produced during the previous month, 1 pair is produced during this month. So now we have 2 young pairs, right? So the total number of pairs of rabbit that will be available will be this 1 plus this 2, that is equal to 3, right? 3 pairs. Now what will happen? After 4 months, the pair which was produced here during the third month, it will become 2 month old, right? So this 2 pair, 1 pair is now 2 months old, will now become a old pair, and now it is able to produce another pair of rabbit. So the older pair of rabbits now are one was the original pair and one which was produced but has become old enough to produce or to reproduce, right? So what will happen now? These 2 pairs are going to produce 1 pair each. So 1 pair is produced by this pair, another pair is produced by this pair, and 1 pair which was already there will be also here. So the total number of newborn pairs are, newborn means those which are not 2 month old, or rather less than 2 month old. So now we have 3 pair of them and 2 pair of those which are now in the age of reproduction. So 2 plus 3, total number of pairs will be 5. So I hope you got the drift that in which direction we are proceeding. Now if I have to formulate this as a mathematical problem, how will I formulate it? So formulation requires a very smart approach, and what we are going to do, we are going to represent Fn is the number of pairs of rabbit after n months, right? Fn represents the total number of pairs of rabbit after n month. So how the Fn will look like? Fn will be equal to what? Fn will be equal to Fn minus 1. What is Fn minus 1? uh, the number of pairs of rabbit which are there at the end of n minus 1 month, right? Now we are already aware that no pair of rabbit is dying during this process. So let us understand it through a simple example. Suppose I ask you how many pair of rabbits will be there at the end of 12th month. So the total number of pair at the end of 12th month will be equal to total number of pairs at the end of 11 months plus the number of pairs which will be produced during 12 months, right? So at the end of 11 month, that will remain, that F11 will remain, plus we are also going to have those pairs which are being produced during the 12th month. So how many such pairs will be produced during the 12th month? All those rabbits which are there at till the end of 10th month, now they are old enough to produce during the 12th month. So each of them, suppose F10 of them are there, so each of them are going to produce one pair of rabbit. So the total number of pair at the end of 12th month will be equal to F11 plus F10. So this is what we have written here. The total number of pairs of rabbit at the end of n months will be equal to number of pairs which were there at the end of n minus 1th month and the total number of pairs produced during nth month. So how many pairs will be produced during n months? It will be equal to the total number of pairs which were available at the end of n minus 2th month. So this relation is the recurrence relation. And what will be the initial condition? The initial condition will be that F1 is equal to 1 because in the beginning we just put one pair of rabbit on the island, and during the second month also that was equal to 1. So F1 is equal to 1 and F2 is also equal to 1. Now if you write the sequence, how it will look like. So F1 is equal to 1, F2 is equal to 1, F3 will be equal to F1 plus F2, that is 2. F4 will be equal to F2 plus F3, so that is equal to 3. Then the next will be 2 plus 3 is equal to 5. Next will be 3 plus 5, that is equal to 8. Then 8 plus 5, that is equal to 13, and so on. So the sequence that we have got is known as the Fibonacci sequence, and the formulation I hope you have understood. In case if you have not, please pause the video, think about it, try developing your own logic so that you should be able to understand it. So let us move to the next problem. So here we are going to discuss another interesting problem that is known as the Tower of Hanoi problem. And this is a popular puzzle of the late 19th century invented by French mathematician Lucas and called the Tower of Hanoi problem. So what basically is the problem? I am not going to read it, I am just going to explain. So you can see that here we have three different pegs or three different poles. Let me call it peg 1, let me call it peg 2, and let me call it peg 3. And on this peg there are different discs which are placed. But if you look at the arrangement of these discs, the largest is coming at the bottom, means they are arranged in the decreasing order of their size. So means the largest and then a smaller than that and then a smaller than that and so on. What you have to do, you have to move all these all these discs from one peg to another peg, and during the process you have to use this peg, means you can use this peg during the process. Okay. So we are also not allowed to ever place a bigger disk over a smaller disk. While moving the peg from moving the discs from one peg to another peg, we should always place the larger peg under the a smaller peg, means a smaller peg will always be over a bigger peg. It will not be like in the decreasing order. It will always be in the way, means the larger will be in the bottom and then a smaller will over the top of it. So to understand this, let us take these examples that will help us to formulate this problem easily. Now if you look at this 3-peg example, and I have denoted them by different color: green color, white color and red color. And I am moving all these disks from first peg to the third peg, right? And I am going to use this peg as the intermediate peg. So how many steps will be needed? First we are taking this red and going to move it to the third peg. So this is the first step. In the second step, what we are going to do, now we have this situation. So we are going to move the white over here. Now we have, this is the step number 2. In step number 3, what we are going to do, we are going to place this red over this white. So this is the step number 3. In step number 4, we are going to move this green from the peg A to peg C. So this is how it looks like. Now in step number 5, this red peg is coming to this peg A. Now we have this situation. Step number 6, I will move this over here. So this is the situation. And finally in step 7, we have this situation where I am moving the red disc from this peg to this peg. So this is what exactly we have got. So you might have noted that total number of steps required here are 7. So the question may arise that how many steps are needed in general if we have n disks placed one over the other, the way we have already discussed, and with the condition that you should never put a bigger disk over a smaller disk. So let us formulate this problem. How does the formulation look like? So the formulation is that suppose total number of disks are n minus 1, right, which is lying over the largest disk, means in total there are n disks, and what I am going to do, I am going to divide them in 2 parts. One is the largest disk, that is the 1 disk, and over it we have n minus 1 disk. Now I am calling that suppose Hn represents the total number of movements required, to move n disks from one peg to another peg using the required restriction. So what will be Hn minus 1? Hn minus 1 will be total number of steps required to move n minus 1 disks from one peg to another peg. So suppose I first fixed the top n minus 1 pegs and moved it to this peg in Hn minus 1 steps. So all these n pegs which are there are moved here to here in how many steps? Hn minus 1 step. Now we have a largest disk which is lying at the bottom. So this largest disk will be moved from here to here in how many step? 1 step. Now we have a situation where we have n minus 1 disk on this peg, 1 disk on this peg, and this peg now will be empty. We don't have any disk anymore on this peg. Now the largest disk is already available over here. So what we are going to do, we are going to move these n minus 1 disks over this largest disk in how many steps? Again Hn minus 1 steps, right? So the total number of steps is equal to, Hn is equal to n minus 1 steps, Hn minus 1 steps that I have taken to move this top n minus 1 disk. So Hn minus 1 steps plus the 1 step that I have taken to move this disk from here to here plus 1, and again we have n minus 1 disks over here which I will move back to the this peg. That will also require us to perform Hn minus 1 steps. So the recurrence relation that we have got is 2 times Hn minus 1 plus 1. And what is the initial condition? H1 is equal to 1, because if we have just one disk, it will require 1 step. So this is the formulation. Okay.